All right. We are doing 2022 AB1, and we have the rate that vehicles arrive at a toll plaza is given by this lovely function right here. Now, because this function is so lovely, we are just gonna spit her into y1. So we're gonna do 450 root sine of 0.62x and call it a day, and we'll see what happens whenever we look at her. Part A just says, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. Since we're just looking at the total number of vehicles that arrive, and AFT is the number of vehicles that arrive, then, and that's the rate because that is vehicles per hour, we are going to take the integral from 0 to 5 of A of t dt. That's it. No need to do anything fancy. Part B says find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. Okay, now this is kind of where we need to think about what it's asking us. It's talking about finding the average value of the rate in vehicles per hour, which means that our answer, our unit, needs to be in vehicles per hour. So AFT is already in vehicles per hour. If I take the average rate of change, that's going to be vehicles per hour. I don't want that. So whenever we take the integral, that's going to put us back to vehicles, but then we're going to spit out that 1 over b minus a, which is why we're going to be using the average value formula. So once again, think about your units here. Oops, not. Now, 6 a.m. was time t is equal to 1, and then 10 a.m. was time t is equal to 5. Oh, I forgot to mention that on part A. But be careful with that also, because time t is equal to 0 is at 5 a.m. After 5 a.m. Okay, so we are going to, let's see, nth derivative her, 1 to 5, y1, and then we are going to do 1/4 at the end. Oh, that's nasty, times 0.25. So that gives us 375.5369 vehicles per hour. Now, do you need to include the units? No, because they've already given you the units. But it's there just so that you know and understand that we're not using the average rate of change. Part C says, is the rate at which vehicles arrive at the toll plaza at 6 a.m. increasing or decreasing? Give a reason for your answer. Okay, so it's talking about the rate, and is it increasing or decreasing? So we need to take the derivative of A of t at 6 a.m., which is going to be a prime of 1. All right, so then I'm going to do alpha. Oop. Okay, what's happening here? I'm going to do alpha trace y1, 1. Oops, not 4. Why did I say 4? 1. And that gives us that right there, 343.0154. Oh, wait, no, just kidding. Don't do that. Don't do that. I haven't even taken the derivative yet. Okay, so y2 is going to be my derivative. We're going to use y2 instead of y1. Of 1. And that gives us 148.947. That's much better. Oops. Now, because that value is greater than 0, this is going to tell me that the rate at which vehicles arrive at 6 a.m. is increasing because a prime of 1 is greater than 0. Okay. A line forms whenever a prime of t is greater than or equal to 400. And the number of vehicles in line at time t for a is less than or equal to t, which is less than or equal to 4, is given by this lovely function right here, this integral, where a is the time when a line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza and the time interval from a is less than or equal to t, which is less than or equal to 4. All right. So, what we're going to do here is just take the derivative of this, since we need to find the critical point. So this just becomes a of t minus 400, which kind of makes sense in context because we want to see when the line forms when a of t is greater than or equal to 400. All right, so we are going to put this into the calculator and see what happens. I'm going to change my window so that it is from 0 to 4. I might change my y min and y max. I'll change my y min to 0. My y max, I'll probably change it. Maybe, maybe not. I don't know. We'll see. But what's going to happen here is I need to figure out a of t minus 400. A of t is already y1, so I'm going to do y1 minus 400. And then I'm going to graph this. Oh, Jesus. Okay. Don't graph the whole thing. Graph only y3. Okay. So, my calculator automatically gave me one of the zeros. So t is equal to 1.46937. Well, in this case, that's a sub 1. And then I guess we could say a sub t is my other 0. So I gotta figure what that is. Okay, this is taking a while. Okay. That's going to give me 3.59771. So, since we want to find the greatest number of vehicles, right, we are going to do n of t and t. The first one's going to be 1.46937. The second one's going to be 3.59771. And then the fourth one is going to be 4, since that is my endpoint. All right, so we are going to go ahead and put this into y4. Now, remember that because this is under y4, whenever we de-evaluate this, we got to make sure that we're typing in y4 instead of y1 like that other video. We are going from 1.46937 to x, and then we have y1 minus 400. Well, if t is the same value, then that's just going to be 0. That's essentially when that line starts to form. Now y4 of 3.59771 gives us 71.254. And then y4 gives us 62.338. Now, because it's talking about to the nearest whole number, and it's talking about the y value now, I'm not trying to give them the time. No, just tell them the greatest number of vehicles, in line is 71. Call it a day. All right, for number 6, we are going back to no calculator. And 7 and 8.